Okay, Alisa, this is session 3. So I see that we already talked about linear search enough. Let's move to how to say, let me see here. Let's talk about, yeah, binary search. So binary search is actually kind of a very efficient. Alisa, can you hear me? Alisa?
Oh, I didn't realize I was muted. Yes.
So binary search, actually, we are trying to reduce the amount of comparison that we're going to do to be able to search an array. But the first condition, or the only condition that you must meet before you use a binary search algorithm or a code to do the binary search, is that you have to sort your array. So you cannot use unsorted array. It will not work. So if you have an array, you have to sort it first. After this, you can use a binary search, and then you will find yourself in 3 or 4 steps or 3 or 4 comparison. You are finding your item that you're searching for. So we have to always order the list. Yeah, actually, the list can be ordered as in an ascending order from low to high, or even from high to low. Okay, and let us have a look here with some kind of code, not code, but here. So Alisa, have a look here. This is an array that have 7 items, and let me see what he's searching for. So he's searching for 25. So item 25 is here. So what we do in the binary search is that we go divide the size by 2. So it means that 7 by 2 is 3.5, but 3.5 is, there is a position here, right? It doesn't lead to anywhere. So we somehow try to take the floor of that number. The floor of 7 divided by 2 is 3. So we go to the position 3 here, okay? And we say we want to compare our number here, 25, to 15. So, and then the comparison. So if they are equal, okay, we are done. We just go back with the current, with this index. So if we are not, then we start comparing 15 to 25. So 15 is smaller than 25, right?
Yeah.
So it means that we need to start looking at the second half of the list. So we start to assign our next half as, so we say, okay, our array that we would like to search in is no longer from 0 to 6. Is actually from 3 to 6. So we start, we mark the start position as here, and the end position is somehow here. And then we try to, no, sorry, we don't mark it as here because we already searched
Yeah,
here.
it should
We
be at
mark,
4, right? Yeah.
we start here, and then we mark our middle position as here. Okay, so the first, the second comparison that we'll do, we will able to find 25. So it
Got
means
it.
that we do only 2 if statements, and from there we are able to find our search, our target number here. So
Yeah.
let's have a look at how the code looks like. So again, yeah, and so this is how we do it. We check, this is the middle point, and then we make here the start, here the end again, and we take the middle this way, like I told you. And then let us have a look at the pseudo code. So okay, sorry, Alisa, let me try to take the call, please.
Yeah.
Okay, give me a second, please.
Uh,
Okay, so yeah. Alisa?
Yeah.
Are you following? Okay. So we here have a while loop, and we that have two conditions. So first and last, this is the marking for the start of the array, and last is the marking of the last element in the array. But again, these two variable we will use to be able to how to say we will be able to change them based on which portion of the array we would like to search. Did I make any sense so far? Not yet.
Not. Yeah, not yet.
Okay, and okay. So do you still remember that we marked a midpoint of an array here? Let me see here.
Mm-hmm.
So we mark it a midpoint, right? But when we mark it a
Wait.
midpoint,
Sir, can you like zoom up on the code because it's kind of hard to see from here.
okay, it's even harder for me.
Oh. No, like
Oops. Okay,
zoom
okay,
up.
yeah. Okay.
Yeah.
What about now?
Yeah.
Okay, good. So what I wanted to say that, okay, we have first and last, and first mark if we have an array like this or a list like that have items
Mm-hmm.
from 0 to 6, for example. So the start mark here, and
Yeah.
this marks the last. Okay, and then we try to find the midpoint, and we said at 3, position 3, right? And so again, we divide it by 2 to be able to find the midpoint. And then we start searching the midpoint. This is an if statement that have multiple possibilities. The first possibility is
Mm-hmm.
that you find what you're searching for. Here we find 15, and we are searching for 25. So we first search item contain 25 here, and this is what the element contained in the midpoint, which is 3. So we compare it first. If we find it, if they are equal, then we say, okay, we found index is a midpoint, and then we say found true. It means that we will not loop again. We will just exit. Okay. What if it is not? If 25 is not equal 15? So we go to the else, and we would like to see what is happening here. So this 15 is bigger than 25 or smaller than 25. Based on that, we will focus our attention either here or here. So if we are not searching for 25, we are searching for 10, and this is an ordered list, it means that definitely the numbers that we're searching for is somewhere here, not instead of here. Did you get me?
Yeah.
So it means if we searching the midpoint here is smaller than 25, so if 15 is smaller than 25, it means that we need to adjust our first, the start from here to become somewhere here. So it is midpoint plus 1. So this is the midpoint. So midpoint plus 1, it means you go to the position 4. Did I make
Mm-hmm.
sense? You
Yeah.
see? Okay. So what if it is not? What if the number that we're searching is 10, not 25, and we need to search here? So what we're going to adjust? We will not adjust our start. We will adjust our last position. So instead of last looking at the last element in the array, it should look here one step under the midpoint. The midpoint is 3. So minus 1, like that. You will get the new last position, and then you start searching here. By going through the loop again, it will find the new midpoint using the first and last, and so on. Did I make
Mm-hmm.
sense? So the
Yeah.
next while loop, it will consider the array not from here to here, but instead from 0 to 2, because now the last is not looking at 6, it's looking at 2. So you find the midpoint here at 1, and then you do the comparison and so on until both first and last become somehow equal, like this, or you find. Can you tell me what did you get and what is difficult?
I got it. I'm copying the pseudocode right now, actually.
Okay. Alisa, are you done?
Yes. No,
Okay.
almost. Give me a
Okay.
minute.
Yeah, sure.
Okay.
Okay, good.
Yep.
Mm-hmm. Okay, so let me see here. This is Python, this is VB. Okay.
Mm-hmm.
So the difference, there is of course a slight differences between pseudocode and VB.NET. The variable names will remain the same, except that in pseudocode we use div to do this integer division. It means that if you divide something like this, it means that it will just so if this is 3.5, it will just remove that portion and get you only the 3. So this is div in pseudocode, but here in VP is this slash. So do you see the difference here?
Wait.
Uh-huh.
This kind of slash, what's it called again?
So
Uh,
I believe we take it in the first 2 or 3 lessons.
yeah.
This is
Oh, okay.
similar.
Got it.
Yeah. So yeah.
Check my note.
Okay, good. So I think,
Does
if I'm
that
not
mean
mistaken,
sorry.
yeah, say please.
Does that mean that in pseudocode, if I want it to be a integer, it has to be like div? Or
Yes, this is one of the ways. And also, but again, this is, I mean, this is the kind of division that give you that. And if you want, there is another function called int. So this int, if you give it 2.5, it will return to you 2. So, but this is a division. This is it's an integer division that give you only the integer portion of that is resulting from a division. So if you say 7 div 2, it will return to you 3, and so on. But if you want to convert a double, you can use the function int. This is in pseudocode. So div and int is in pseudocode.
okay.
Make sense?
Yep.
So if you see here, Lisa, here you find that this VP exactly the same. First, we check if the middle point, if the item we are searching for is exactly here in the middle point, that from 0 to 6. And if it is not, then we check, we try to check. Here there was 15, if I'm not mistaken, and we are searching for 25. So we're searching, okay, 25 is bigger than 15, right? So we have to search
Yeah.
on this portion. And if it is not, then we have to search on this portion. If we are searching this portion, it means that we need to shift our the first position in our array to be midpoint plus 1. If it is not, then we have to shift our last point from here to be pointing to here. Did I make sense? So this is exactly the same like pseudocode. Same concept,
Okay.
except that we are not using arrows, we're just using equal.
Ah.
Did I make sense?
Yep.
Did you finish copying?
I'm just like making notes about the fact that it's almost the same in VB.NET, honestly.
Okay.
Okay.
Okay, good. So I would say you will be surprised that, okay, if we, I think, no, there is something here. I think talking about comparison, never mind. I think it is here, yeah. So I will list to you the number of comparison that we need to do. If we have 10 items in a list, then we will do 4 comparison. Can you see that here? Okay. And if we have a million item in the list, we will only do 20 comparison. Can you see the difference between this and the linear search? You see that we are reducing the amount of comparison. So it means that we are finishing comparison very fast. Okay, but how actually we know the number of comparison that we actually need to perform? So they tell us that to know the number of comparison, we have to divide the item in the list by 2. So we keep dividing it by 2 until we reach 1. And if we divide by 2 this way, we have to use the div, which means that we only, div like that. It means that we take only the integer portion. So 10 divided by 2, it gives us 5, it's fine. 5 divided by 2, it gives us 2.5. And then we neglect the decimal point and we take the 2. And then we divide it by 2 again, it gives us 1. So how many comparisons what we have done? 3 comparisons. So if you have 10 items in the list, then you're able to know that, oh, you do 3 comparisons. Does this make sense?
Yeah.
Okay. And so again, to be able to calculate the number of comparisons, this is the way. And then we have a look at, again, So we always look at the worst case scenario, and if you see now the graph again, the big O, you have to look at the theoretical part for that. Although this exact thing actually you need to memorize. For the binary search is O log n. For the linear search is O n. This is, and they have a table. I'm able to pass you the table. It have 3 or 4 items, 5 items if I'm not mistaken, and you just need to, this is 2 of them, so you have remaining almost 3 items. You need to memorize what is the time complexity or the big O for different algorithms. This is 2 of them. We will take more. Okay, just memorize that and you will be fine. Okay.
Okay.
So what I want to say is that the more number of items, we don't actually consume too much time, similar to the linear search. Linear search, it was a linear relation. The time increase when we have more number of items. Here, no. We don't grow so big on the number of comparisons. The more comparisons that you do, the more time that you consume. Did I make sense here?
Yep.
Okay.
Okay.
Okay. Yep. Let me see here. So again, let me. So one of the string functions that you can use, Alisa, here is that. Let me have a look here. Yeah. So one of the string function in pseudocode is that you are able to use the meet function. Did you see it before or even hear about it? Did you hear about it?
Yeah, it was in pseudocode.
Yes. Okay. So I no need to explain it, right?
Yeah.
Okay. Good. So can we move to take the 2D array? I think we still have time. Let me open the Visual Basic here. So Alisa, we will take the 2D arrays. That will give us also a slight push forward. So the 2D arrays works exactly the same like the 1D. So again, to me, especially in VB, the tricky part is the size of the array. So if you see here, you define 2 rows and 3 columns. So it's actually 3 is here. So actually you're not defining 3 columns. Actually it is 4 columns. 3 represents the last column that you have, and 2 represents the last row that you have. So if you write here 2, actually it means that you have 3 rows. And if you write here 3, because it is from 0 to 3, you have 4 columns. Does this make any sense to you? It doesn't make too much sense. It is confusing. I understand. So it means that you are able to, in other programming language, you are not able to write, if you are creating a size of 3 like that, you are not able to access that 3. That is only for defining the size. But here in VP is slightly different. So if I would say, so do you see the code here? So you see that is a code from a book. It is supposed not to have as much as missing items as possible. So he's defining 2. I mean, we're having a row from 0 to 2 and columns from 0 to 3, which is mean that it's total 4, and here total 3 through 3 rows and 4 columns. But you see here he didn't put he only put he put in the matrix some items, not all. He didn't fill in all the matrix. He didn't put until, so he stopped at row 1. He didn't use row 2 at all, even though he's able to do it without a single mistake. And we are able to see that. And he didn't even use column number 3. So he stopped at column number 2. But actually, if we copy the same code like that, we are able to run it. Let me see here. Yeah, so I can delete this portion. No, I need that portion. Sorry. Yeah, I need it. So, okay, Alisa, can you still see here? I think I better remove that here. So, Alisa, I would like you to tell me, please, line number 29. Will it run or it will have a problem?
Line number 29. 29?
Mm-hmm.
Can I see how many?
Yes.
Oh, yeah, no. There's like too many. It's, it's like not in the array.
Okay, so let's comment it here. What about these two?
Mm-hmm. For these two, should be fine. Yeah.
So again, can you remind me? This is refers to the row or column, and this refers to row or column.
Oh, if I remember correctly, it's row and then column.
Yes. Okay. And then if you would like to create a for loop to loop through the for loops. Okay. So now again, here you can see when he print matrix, the matrix position 0 0. So he print 10. Can you see that?
Yeah.
And for second row and the first column, he print 20, which is here. And then forget about these 3 because I didn't correct that. But what I want to say is that, can I know when he says second row and second column, why it is 0? Can you tell me, please?
Because it's like blank.
Are you sure? Aha. Tell me again, please.
Oh, second row, second column. Wait, where's
So this is the one.
Because it's matrix 1 1.
Mm-hmm. Okay. And why is it 0?
It's not like assigned a value up there.
Perfect. You are correct. Yes. Okay. That's good. Okay. It's done. So again, just let me share with you, if you would like to go through, I think you still remember when we gone through, let me see here if they have a code for that. No, they don't have a code for that here, but okay. So Alisa, I will give you an exercise where you need to actually go through loop through a 2D array, but then you will try to use 2 for loops. The first for loop is for actually the rows. The second for loop is for the columns. But actually, how you do that? So this is for, and for r or row equals 0, 2, whatever, and then we say next row and then we make an inner loop for column, okay, for column equal 0, 2, whatever. Then we say next column. And then you put whatever. So if you use this way, you are able to put the matrix and you put row like that and column like that and put them in a print statement. Did I make sense here to you? Alisa?
Yes.
Tell me, did I make sense here? I'm explaining to you how you can make a for loop that can work for 2D arrays.
Yeah. No, I'm sorry.
Copying.
Yeah.
Okay. Do you take another classes, Alisa? I mean, other with other tuition, like which subjects you take?
Oh, I don't take any other ones. Usually I just study with my friends.
Oh, okay, that's interesting.
Yeah.
Okay. No, but I'm not trying to find to know more information, but I wanted to compare how you deal with other tutors, if they are fast enough for you to, because okay, I dealt with people, yes, in who, I mean, different abilities, but this is the first time to deal with ADHD. I dealt with people who have um, lower IQ a bit, but of course you are on the higher side, so yeah, it's slightly different. I think you could be the smartest so far that I dealt with.
Oh, that's nice.
Yes.
Actually, one thing I don't really get, what is it to? Like, for row equal to 0 to
Okay, because
what?
okay, when you have 1D array, so again, um, consider the 2D arrays. No, let's go up here. Why we need 2 for loops? It doesn't make sense, right? So if we look here, then we are able to divide this matrix into actually 3 1D arrays. So this is the first 1D array. This is the second 1D array. This is the third 1D array. Third 1D array. So it means that he deal with everyone individually. So it means that the first for loop, talking about rows, so it will give, when we come here, this for loop is responsible for passing that whole row to the second for loop. So when we say row 0, this is a row 0. And then inside row 0, he will go through every element using the column, starting from column equal 0, column equal 1. So that this column value will keep increasing, but the row will be fixed. The row will start with 0. So we will loop through this. We will not loop A, E, I, no. We will loop A, B, C, D. After we finish it, we go E, F, G, H. Then we go I, J, K, L. Did you get me?
Yeah, got it.
Not yet. Really?
No, yeah.
Okay, so again, let me pass you some exercises about the 2D arrays, and hopefully you manage to do them. Okay.
Yeah. Okay.
Okay. Then see you next class.
All right.
You have any questions?
I think
Any
it's
request?
so far so good because I haven't actually tried any like questions using this, but concept wise, I got it.
Okay, perfect. Okay, so if there's no comments, then we end it here and see you next class. Okay.
Okay, thank
Okay. See you. Bye
you.
bye.
Bye bye.